Derek Dooley, former University of Tennessee football coach now. Pulling two carts connected, coupling force is given. We want to determine the force P. So we've worked lots of problems like this. We give a little bit of a hint here that says there are two free body diagram and kinetic diagrams required. That's sort of implied by the fact that you're given information about the coupling force, 12 newtons. So we'll have to draw at least one free body diagram that has that in there. And if you think about it, that's helping us determine the acceleration. Okay. So I only have a couple choices. I can draw a free body diagram of the whole system, which is probably what I want to do at the end. I can draw a free body diagram of the second cart. That's going to have just the coupling force in it. I can draw a free body diagram of the first cart. So that would have the pulling force, which is unknown, and the coupling force and an acceleration. So the key here is this free body diagram of just this cart 1 would have two unknowns. A free body diagram of cart 2 will just have the unknown acceleration since we're given a coupling force. So that's the sort of thing you want to think about when you're working these problems. So let's start off with cart 1 here, or excuse me, cart 2. And we'll have the weight, and we'll have the normal force, and we'll have a coupling force. Okay, and the kinetic diagram for that is going to be a mass times acceleration. And we'll use standard coordinate system. Alright, so that works out pretty easily. We know C equals MA. This is given as 12 newtons. Okay, we've drawn a free body diagram just of cart 2. So we use just its mass, 20 kilograms, times acceleration. Okay, so that's going to give us acceleration of 12 newtons over 20 kilograms. Okay, remember that 1 newton is equivalent to kilogram meter per second squared. So that will give us units of meters per second squared. And that looks like about 0.6 meters per second squared. 12 over 20, 6 over 10. Okay. So now we have an acceleration. That's acceleration of cart 2. It's also the acceleration of the whole system. So we can draw a free body diagram, kinetic diagram of 1 and 2. We could also do just cart 1. We would have to factor in the equal and opposite coupling force, but this, using a whole system, has one less force, so works out a little bit easier. P weight N, and it's going to have a mass times acceleration. So another very simple equation, P equals MA. P is what we're trying to find. This M is the mass of the whole system, so it's going to be 20 plus 30. And this A is acceleration we found over here, 0.6 meters per second squared. Alright, so it looks like 50 times 0.6. It gives us about 30 kilogram meter per second squared, and we just saw over there that 1 newton is a kilogram meter per second squared. So 30 newtons.